Okay, good morning. So, welcome sa ating part 2 ng Introduction to Geodesy. So, I will be discussing the definition and what are the branches of Geodesy. So, let's start. So, geodesy is one of the oldest profession in the world which is practiced by man. So, commonly they observe the stars and natural objects to determine the position on the earth. So, the word geodesy comes from the term geo, means earth, and daisa means to be divide. So, if you combine, that is geodaisa or dividing the earth. So, by classical definition, so geodesy is being defined as the science of measuring and portraying the Earth's surface. So the modern definition of it becomes, so geodesy is discipline that deals with the measurement and representation of the Earth, including the gravity field in a three-dimensional time varying space. So medyo broader ng kanilang definition. It takes account na ng gravity field ng Earth bilang measurement and representation of the Earth in form of a maps or a model. Okay. So, si geodesy is geoscience also that contribute to our understanding of the solid earth, atmosphere, and science. So, geodesy has a branches of science concerned with the following. We have determination of the size and shape of the earth. Ito yung pinakauna, which is the geometric geodesy. Determination of ano ba yung exact position ng points, either above, below, or within the earth's surface, and description of its variable gravity field. Ito na talaga yung three main purpose and goal ni geodesy to determine the size and shape ng earth, to determine the position ng mga points, and the variability ng gravity field sa surface ng Earth. So, surveying is the practice of positioning to determine the position, while geodesy naman is the theoretical foundation of the geodesy. So, siya na yung naging theory, and the surveying is the practice. So, the geodesy has three pillars, or ito yung foundation ni geodesy. We have number one, geodesy of the Earth's surface and their time variation. We have number three, Earth rotation and the polar motion, and the Earth's gravity field and its time variation. Okay. Here are some of the modern geodesy tools that we're using in the modern geodesy. For geometric techniques, when I say geometric techniques is the determination of the size or position on the surface of the Earth. We have GNSS or the Doris SLR. For the ocean and ice mapping, we have the instruments such as satellite radar and laser altimetry, which is in laser na ang pag-determine ng altitude ng points. We have topographic mapping. We have using the SAR, an Earth observation mission. We use the satellites to determine the topography of the Earth. We have for the gravity mapping, we have you can use, as you can see, the box at lower left. We use this instrument in measuring the gravity on the surface of the Earth. So I have here in So if you have your internet connection, you can watch this video, The Impact of Geodesy. So this video explains what is the contribution of geodesy in our daily life or in the community. So please watch this video, just a short video. Let's continue. So we have domain of geodesy. The first domain natin is to determine the position. Number two, we have determination of the Earth's gravity field. And so number three, when we say temporal, that is the changes with respect to time. Temporal variation of the position and the Earth's gravity field. So for the number three, that is the combination of number one and two. The position with respect to the Earth's gravity and the changes of time. So when you say positioning, so that is the question, where am I on the earth? So exactly is the determination of the position. For number two, determination of the earth's gravity field. So is there any gravity in my absolute location? So it explains, or the output of this one is a, gravi a gravity map on the surface of the earth, or a gravity model on the surface of the earth. It is the gravity varies or changes with respect to the location. So if you are in the North Pole, Is it different gravity field that you are experiencing if you are in the equator? So it varies. So it changes with respect to time, it varies and with respect to the location. So we have here geodetic activities. So for example, meron tayong mga theory. The theories we have here, when we say theory, ano yung nalalaman natin without the action. So data, mag-acquire tayo ng data, nagpo-process tayo ng data, and we represent this data into information, or for example, into a map, into a model, and we utilize those data in the form of information system. So these are all a theory. So we do not conduct this in the practice. Well, in the practice naman, so we apply this method, data acquisition, data processing into the surface of the Earth. For example, pwede tayong mag-acquire ng data sa land, sa sea, atmosphere, sa space, and we process those data, represent those data into a maps, and utilize this data in a type of data information system. So the practice would be this theory, it will become practice. This term is now called the geomatics. As you remember the definition of the geomatics, di ba? We measure and we analyze this data acquired, and we utilize this data and we create maps. So that is geomatics. So observation in the surface of the earth. Okay. So meron talang connection si surveying. Surveying, that is the old term for geomatics. Si surveying and the theory, which is for the geodesy. So geodesy has a lot of branches, and two main of its branches is the geometrical and the physical geodesy. So when you say geometrical geodesy, so concerned lang siya in describing location in terms of geometry. And basically, yung kanyang product, your primary product niya is we call the coordinate system, o yung mga coordinate system. So these topics or these branches will be focused on this subject. When we see naman physical geodesy, so it is concerned with determining the Earth's gravity field, which is necessary for the establishment of our heights. So this is so another we have dynamical geodesy. So it allows lang determination of the Earth's gravitational field pa rin from the observing the artificial satellites. So similar siya kan satellite geodesy. So we have here another, the mathematical geodesy, which is similar to geometrical geodesy. It uses theories and formulas in determining the size and the shape of the Earth. Here, satellite geodesy, which is very common if this is your next subject and next year. So this satellite geodesy is concerned with the using orbiting satellite lang to obtain the data for geodetic purposes. So gumagamit tayo ng mga satellite objects, mga artificial satellites to determine a position here in the surface of the Earth, so which is widely used today. Another, we have marine geodesy. So marine geodesy this aim is to stimulate progress in the ocean surveys, either mapping and remote sensing by promoting problems regarding the research-oriented marine environment. So focus siya sa water. Have naman another, have here, geophysical involves the physical properties of the earth and others. So there are lots of sub-branches. What the main two sub-branches are the geometric and the physical geodesy. So the geodesy is one of the earth sciences. Earth science din siya. Other familiar earth sciences or geosciences are the following terms, which is, I guess you are familiar with this one. We have geography. When I say geography, describes what you find where on the earth. So specifically location when we say geography. And then land, water, climate, vegetation, and man's habitat. So encompass siya sa geodesy. We have naman geology. Pag sinabing geology, the rock formation and their evolution, ano yung impact ni geodesy in this use of the earth sciences. Sa geology siguro, yung ating rock formation is affected by the gravity. So medyo, for example, yung formation niya is caused by the gravity field, nagko-compress or nag-extract yung ating earth crust or yung mga rock formation. Here naman, geomorphology, which describes the landforms and their evolution. We have the geophysics, so it studies the physical forces that shape of the earth, which is very resembling kay physical geodesy. Yaman. So geodesy lang is less known, although it is the oldest of the geosciences. Because nga, geodesy is medyo maliit lang yung nakakilala kay geodesy because of its technicality. Here, the other science, geodesy and the other sciences. So, meron siyang connection kay astronomy. We have atmospheric science, the geology. These are the other sciences. The space science, oceanography, physics, computer science, mathematics. We have hydrography, geography, ecology, engineering project. Especially kay mapping, di ba? We are using the concept of geodesy in mapping. So we create map out of the the ellipsoidal earth. We create map for the urban management because we create a maps. We display features on the surface of the earth. Yeah, for engineering projects, very important. So these are some of the sciences which are related kay geodesy. So why geodesy is less familiar? So I think according to the chairman of the International Association of Geodesy, or its president, he says that it is because in the standard surveying or geomatics education, geodesy subjects have reputation for being the most esoteric. When we say esoteric, masyadong makuri-intindihon and naiintindihan lang siya into a limited circle of people or profession, and mathematically difficult. So geodesy has always been an existing on the fringe of photogrammetry, remote sensing, yung GPS, yung ating mga cadastral, yung ating ginagawang mga survey. So, because masyado siyang scientific compare sa ginagawa nating mga practices today. So, when we say fringes, that is something resembling. So, yung ating ginagawang photogrammetry, remote sensing, GPS, yung GIS, yung nagkakandak tayo ng survey, that all has a connection kay geodesy. Okay? So, maraming practitioner still see geodesy as rather too unrelated to what they do. Especially pag nararan tayo ng traverse. We do not consider, pag plane survey lang, we do not consider the curvature of the Earth. The curvature of the Earth is considered on the topics of geodesy. Okay? Okay, let's focus on the first branch of geodesy, which is the geometric geodesy. So, yung first objective of geometric geodesy is to study the various local, regional, and global reference system. When we say reference system, ito yung magiging basihan ng ating mga surveys, or ito yung basihan ng pag-determine ng ating mga posisyon. So, this, when we say local, ito yung actual na posisyon mo, ay yung actual na reference system na gagamitin natin. When we say regional, kung ano yung reference system na gagamitin ng buong Pilipinas, and the global is sa lahat na. Sa lahat ng kung ano yung gagamitin natin lahat ng reference system all throughout the countries of the world. So that are in use to describe the coordinate of points on the Earth's surface or in near space, or to relate them to each other, as well as the some absolute frame visually celestial frame. So we will discuss this one. What is the celestial frame? What are these reference system? So number two, second objective ni geometric geodesy is to establish coordinate of points that we are need to set up a coordinate system. So with the origin, mayroong orientation and scale. Pag sinabing origin, saan siya nanggagaling? Either sa center ba ng Earth, or um, sa within the position, orientation, or ano yung direction niya, either north, south, east, west, and scale niya, kung gaano ba kalaki, in such a way that all the users are capable of accessing, understanding, and interpreting the system. So, yung goal talaga niya, magkakaroon tayo ng reference system na magagamit consistently. So, ma-access natin, and we can understand and interpret this system. Okay, question. Paano ba tayo mag-establish ng coordinate system? So, I have here, in order to set up a coordinate system, the following fundamental must take care. Number one, kailangan natin na mag-establish ng external o yung inertial coordinate system of our local universe that we assume remain fixed in the sense of no rotation. So medyo parang x and y coordinates siya na fixed, maski nagro-rotate natin Earth, hindi siya na-affect. So number two, kailangan natin mag-establish ng coordinate system attached to our rotating and orbiting orbit, and so doing to find the relationship between these two systems. So, bakit ba tayo nagre-reduce ng ating mga measurement into a plane survey? So, imagine, paano ba nakukuha ni Theodolite yung horizontal distances maski yung ating telescope ay naka-incline? So, we are here in illustration to discuss how our instrument cope up with the reduction of geodesy into planes. So, as you can see in the illustration, meron tayong theodolite, meron tayong prism. Pag yung prism. So, this prism, observe, here, ito yung actual, ito yung close-up ni prism. So, ano yung nakikita natin sa prism, di ba? A series of mirrors. So, when we conduct a survey, we tend to observe the prism in an inclined position. However, the instrument, yung total station, we still give the horizontal distances. Maski naka-incline or medyo mababa yung ating yung prism, yung ating total station is nagbibigay pa rin naman ng horizontal distances. So, paano mo yun nangyari? So, the ADM, yung ating theodolite in the total station, yung ating electronic digital measurements na naka-attach kay theodolite or total station, nagme-measure siya ng slope distances. Di ba? Alam natin yung slope distances by reflecting the laser. Kung ano yung naka-laser. Reflecting a laser beam to a target. So, open ang corner ng reflector is a prism. So, yung prism, meron siyang mirror, marami siyang mirror that are set 90 degrees to one another, forming a corner of a tetrahedral. So, marami siyang, nagpo-form siya ng 190 degrees yung mga mirror natin. So, the tetrahedral always reflect light back in the same direction. So, that's why na-determine natin yung position or yung distances. So, have here another. So, for example, ito yung ating telescope. Ito yung ating prism. So, much higher yung ating prism. For example, ito prism. So, if we set the target to the prism, so yung ating S prime, that is your slope distance. Yung HI is yung height ng ating instrument. And the HR is the height ng ating rod. So, this Z prime, yung ating Z prime, this is yung unreduced, hindi pa siya na-reduce na zenith angle na na-observe ni theodolite. Yung S naman is, ito na yung na-reduce na slope. So, ito yung parallel kay S prime. Si H, ito na yung ibibigay na horizontal distance ni total station. Ito yung Z. So, paano natin nakukuha yung reduce na Z? So, yung Z, i-reduce natin siya in such a way na naka-align na siya kay H. So, if we are using the trigonometric formula, which is sine of Z is equal to H over S. Diba? Trigo. So, sine of Z, opposite, that is, or you can determine H is equals to S, that is your slope distance times the sine ni Z. Now, paano ba natin ma-determine si Z and S? So, ito yung main formula natin. Yung goal natin is to determine S and Z para makuha natin yung ating horizontal distances. So, paano ba nakukuha ni total station yung ating Z? So, we have here, look at the equation. We have cotangent of your Z, that is cosecant ni Z prime, that is yung atong actual na observe na zenith angle, multiplied by HI minus HR, that is the difference in height between your instrument and the prism, plus the cotangent of your Z. So, we can now have the value of our Z. Ito yung ating reduced na zenith angle. Paano naman si S? Si S naman is S prime, kung ano yung actual natin na nakukuha na slope distance times the sine ni Z prime over kay Z prime. So, we can now determine the value of our H. So, yung V natin, that is the vertical distance. How can we determine the distance? Kasi yung ating total station sometimes nagbibigay siya ng slope, nagbibigay siya ng horizontal, and nagbibigay siya ng corresponding vertical distances. So, you can use this formula. Triangle lang siya. You use the triangle HVS. So, we can, V is equals to S cosine of the angle Z. Okay? So, the need for genetic surveying. So, why do we need to reduce our surveys, or why do we need to take account the curvature of the Earth? So, si Geodesy is concerned with positioning across distances. So great that the Earth's curvature cannot be ignored. Okay lang yung pag yung ating survey is 100 distance lang, 500 meters, okay lang yun. What if yung ating survey is to take account in long distances from one cities to another or one place to another na medyo malaki na yung extent. So, what will happen if hindi natin nag-take account yung curvature ng Earth? So, if you are asking kung meron ba talagang dapat na curvature or how quickly does the curvature increases with respect to the distance from the observation station. So, gaano pa kalaki yung ating curvature, nag-changes kung gaano kahaba yung ating minimeasure na distance. For example, meron tayong illustration. For example, ito yung ating curve na Earth, a portion ng Earth. So, ito yung ating center ng Earth. And meron tayong observer, yun yung ating GE. For example, nagme-measure lang tayo ng point A na malapit kay surveyor. So, yung ating curvature is hindi natin masyadong na-observe or hindi natin siya masyadong nahalata because limited lang ating distance from the point to observer. So, nane-neglect lang natin yung ating value ng H. However, pag sobrang layo na ng point. For example, nandito na siya sa other latitude, near na kay equator. For example, sobrang layo na niya. What will happen to the curvature? So, imagine, sobrang laki na ng curvature. The curvature is the h, the value ng h. So, from the foot of the observer up to this one, that put up to the point here above. So, ito yung ating magiging value ng h. So, at point A, h is almost negligible. Pero pag malapit lang yung observer sa kanyang rod, what if sobrang layo na ng kanyang dapat i-observe? So, hindi na dapat natin i-neglect because it will cause na an tantamount error, value ng error. So, it will needs to take account, kailangan natin siyang i-reduce. So, how can we reduce this error? We use the formula of this one. So, I am going to show you how can we determine the value of the curvature under the refraction or the value of yung h. So, as in the similar illustration kanina, we have here the curvature in the position of the rod here and the distance between the 2 points. So, you see yung ating C, H, A, where ang ating A, that is the radius of the Earth. Yung C natin is the geodetic distance, which is yung curve distance from the observer to the point. Yung ating H is the curvature and the refraction correction. So, how can we get the value of H using this illustration? So, may nakikita tayong triangle, di ba? Mula theta, right triangle kay S hanggang sa A plus H. So, yung theta natin is C over A. Paano siya naging C over A? Kasi pag nag-change yung ating angle, nag-change din ang ating value ng C, which is directly proportional sila. And, here. So, kung cosine theta, pag gumagamit na ng cosine theta, that is adjacent over hypotenuse. Kung makikita nyo yung triangle, si theta, meron tayong adjacent ni theta, that is A, and opposite ni theta is S, ito. And hypotenuse of that triangle is A plus H, diba? So, cosine ni theta, that is cosine C over A, yung theta natin, diba, is C over A, is equal to yung ating adjacent, which is A, over yung ating hypotenuse is A plus C. Nakikita nyo sa triangle? Okay. Paano natin siya exemplify? So, if our aim is to get h. So, yung a plus h natin, ilalagay natin siya sa left side. Tapos, yung cosine c over a, ilalagay natin siya sa ibaba ni a. So, yung cosine, pabaliktad, magiging secant na siya. So, a plus a is equals to a, secant ni c over a. So, to simplify, yung h natin is equals to a secant c over a minus a. So, this is now the formula in computing the value kay h. But we have other formula in computing h pag may given na value ng a or the radius ni a. So, this is how can we determine the value of the curvature and refraction correction pag given ang ating geodetic distance and given ang ating radius ng Earth. Okay. So, we have to take note of the following. So, the trigonometric function arise frequently in geodesy. So, and this relationship are re-expressed without the function. And common way is to represent the function by its polynomial representation. Dapat naka-polynomial. So the trigonometric function requires polynomials with the infinite number of terms called the infinite series. So as we go on to the topic, I'm going to discuss the uh, computation of your h in infinite series or in polynomial representation. So this is an exercise. I guess you can do it at home. Use the guide on the last slide to determine. So derive the equation for reducing the zenith angle down to mark. And for number 2, if we have Z prime 89, 1450, your height of the instrument is 1.653 and your HR is 2.015. Find the value of your Z. So you reduce the angle Z. So the answer I guess is um, not not so far from the value of Z prime. So I have here additional information about the International Geodetic Community. So these are the community who established a reference system, a reference frame. So I have here information about the IAG. So yung ating International Association of Geodesy, ito yung was created in the Europe in the year 1862. So it expanded to European arc measurement. Yung una, kasi di ba nag-measure yung sila ni Picard. So in the 1866, the International Association of Geodesy, naging IAG na siya. So it important, ano ba yung mission ni IAG or ano bang gamit ni IAG? So the advancement of geodesy, it is implemented by further geodetic theory through, we have here research and teaching. Nagko-collect sila and then analyze modeling and interpreting observation data. Sila yung nagko-collect ng mga gravity measurement. Sila yung nag-analyze ng ating mga reference system. We have here by stimulating technological development and nagpo-provide sila ng consistent representation of the figure, rotation, and gravity field of the Earth and planet. So sila yung naging sila yung main person na nag-create ng ating Earth model, kung ano yung nakikita natin ngayon. So, these are some of the objectives ni IAG. Study all geodetic problems related to the Earth observation and global changes. Establish sila ng reference system. This is the most important goal and objective ni IAG. The deformation of the Earth's surface, including the ocean, ice, so overall ang kanilang coverage. Nag-innate, coordinate, and promote international cooperation and knowledge exchange through symposia. Nag-create sila ng mga seminar para yung mga reference system na ginagamit ng ibang-ibang bansa is magiging consistent all throughout. So, sila yung mandated to group this community. So, yung goal niya is to foster the development of geodetic activities and infrastructure in all regions of the world, taking into consideration the specific situation of developing countries. Ito yung goal ni IAG. So, this will be the end of the part 1, which is the introduction. So, the chapter 2 is all about geodetic astronomy. So, If you have notes already, you better read those notes before we start the lecture of the geodetic astronomy. Okay?